A very good morning and a good day to you. I'm Sharon N. Thomas from the Department of Mathematical Sciences, Faculty of Science. I am here today to present my research proposal entitled Application of Susceptible Infected Exposed Remove, which stands for SIER, Mathematical Modeling on the Spread of Chickenpox Disease. Let's look into the introduction of this research. Basically, the varicella zoster virus, which stands for VZV, which causes chickenpox, is highly contagious and affects children and people of all age groups. Therefore, by this research, we will be understanding the dynamics of its transmission by using the mathematical modeling within a population. The mathematical modeling that we will be using is, as mentioned in the title, SIER model. By utilizing this model, we aim to gain the insights into the temporal evolution of the epidemic and assess the impact of various control measures and predict the future trends in the disease transmission. Let's look forward into the research objective. Firstly, the research objective of this proposal is to develop the SIER mathematical model tailored to the transmission dynamics of chickenpox, accounting to the incubation period and latent stage. Besides, it is to determine the reproductive number of the developed SIER model to quantify the disease potentials for the spread within a population, to conduct a thorough analysis of the stability of SIER model to assess the robustness and reliability capturing the dynamics of chickenpox transmission. Fourthly, to analyze the SIER model using real-world data and epidemiological information to validate its performance against observed patterns of chickenpox transmission. Proceeding forward, I will look into the literature review. There are many literatures that I have reviewed in order to come up with a successful research proposal. I have explained and searched for articles in defining what is varicella zoster virus, which is chickenpox. Varicella zoster virus is an extremely infectious virus causing chickenpox. It easily spreads to intimate contact, and up to 90% of close contact may contract. Chickenpox manifests as skin rash with small and itchy blisters, fever, fatigue, and its transmission immunity. Besides, I have also gathered the origin of varicella zoster virus. Literatures based on researches that I've done before clearly mentions that VZV virus infection of cells in dorsal root ganglia is likely a consequence of primary VZV infections. The virus may not reach dorsal root ganglia from mucocutaneous lesions through ascending roots along neuronal cell axons or to be carried by infected PBMC before cutaneous lesions appear. I've also attached literature reviews based on the current therapies that are existing to cure the chickenpox disease. VZV vaccines such as valaciclovir and famciclovir are recommended treatments replacing aciclovir. Antiviral medication is safe and effective for treating varicella, especially in adults and adolescents in the illness. Besides, I have also attached many reviews on mathematical modeling that have been used in previous researches in order to control the rate of transmission. However, I do personally feel that SIER model is the most effective model in controlling the transmission rate. Let's look forward into the methodology of this of this research. Basically, there is a simplified version of this model, which is SIR, which stands for susceptible, infectious, and recovered model. However, in this research, we will be using the SIER model, which is extended from the SIR model. This this will allow us to control the rate of transmission of chickenpox disease. Let's looking in detail into the methodological. We can see that we will we will research more about the ordinary differential equation systems, whereby we will have four equations, uh, particularly for the S, which is susceptible, for the E, exposed, I, infectious, and R, recovered models. Furthermore, we will check the stability analysis of these ordinary differential equations. Right? In this stability analysis, we will find the equilibrium point, we will do the Jacobian linearization, and also find the eigenvalues to ensure that those ordinary differential equation systems are stable. Therefore, we can use them in finding the reproductive number, which will which will prove to us whether this disease is able to be controlled or not, whether this disease will be out of hand in the future, or it will be slowly ending in that phase of the pandemic. All right. Looking forward into the significance of study, the finding of this research allows the development and validation of chickenpox, specifically SIER model, which may be used as basis for future investigation into infectious disorders with comparable dynamics. Additionally, the research will improve our capacity to forecast patterns in chickenpox outbreaks in the future, allowing for prompt reaction and resource allocation to successfully control any endemics. As I mentioned above, the reproductive number will allow us to identify this as so. The use of SIER model in the investigation of chickenpox will lead to developments in the future of mathematical modeling and epidemiologically, which could affect the modeling of other infectious illness more broadly. We have come to the last part of our research proposal, which is a conclusion. Therefore, in summary, I would like to conclude that the proposed research on the application of the SIER model for controlling the rate of chickenpox disease is very crucial. Validating this research topic is essential for enhancing our understanding of the disease dynamics and optimizing public health intervention. The SIER model offers a promising tool to forecast and manage chickenpox outbreaks effectively. This will provide valuable insights for targeted control measures, and this research holds a potential significance in advancing our ability to mitigate the impact of chickenpox, contributing to more informed and efficient strategies for disease prevention and control. This is all from me now. I hope this research proposal will stand a strong place and will allow me to learn more in the upcoming semester, where we will calculate the numerical stimulation through MATLAB application, and therefore we can see how can we control the rate of transmission of this chickenpox. Thank you so much. I hope this presentation does justice and is acceptable for the knowledge I could share with you. Thank you.